In this video, we'll be discussing 12 Amazon Route 53 microstacks. This is from systemsarchitect.io and codeguides.io. Subscribe and like this video. A domain name lookup is the very first thing that happens before an application does anything else. And if it resolves to the wrong place or too slowly, nothing after it matters. Route 53 owns that first invisible step, then hands traffic off to whatever's paired behind it: a load balancer, a CDN, a serverless API, an accelerator. Pair it well and traffic finds healthy infrastructure automatically, resilient from that very first lookup onward. Pair it poorly and you get orphan DNS records and silent outages that never show up in application logs. A microstack is a reusable combination of two or several cloud services. We're going to walk through 12 microstacks, proven service combinations for Route 53. Each one shows how Route 53 pairs with the rest of AWS. Together, they deliver resilient, secure, well-routed applications. Each contract, 1, pair CloudFront with S3 for global static site hosting. Route 53 directs users to a CloudFront distribution. CloudFront serves content from an S3 bucket behind it. Together, they put a global website in front of any audience. No one has to manage a single server. Route 53 routes visitors to the nearest edge location. CloudFront caches assets there for fast loading. S3 stores the files durably behind it. This combination removes almost every moving part that could fail. There's no compute to patch. There's no origin server that a traffic spike can overwhelm. It's a natural fit for static websites and single-page apps. Documentation sites that need to load fast globally use it too. A practical tip: set a long cache TTL on your S3 objects. Use CloudFront invalidation sparingly. 2. Route ALB traffic to EC2 for reliable web hosting. Route 53 routes traffic to an ALB. The ALB spreads requests across a fleet of EC2 instances. This gives web applications both high availability and horizontal scale. Route 53 resolves the domain to the ALB using an alias record. The ALB checks instance health directly. Autoscaling adds or removes EC2 capacity to match demand. This pattern is a workhorse for content management systems. It also suits any workload needing more control than a managed platform provides. A useful strategy is enabling connection draining on the ALB. In-flight requests then finish gracefully when instances are replaced. 3. Combine Route 53 with Global Accelerator for low-latency routing. Route 53 works alongside Global Accelerator to optimize the network path traffic takes. This addresses a problem DNS alone can't solve. The public internet is unpredictable and congested. Why pair Route 53 with Global Accelerator at all? Global Accelerator provides static anycast IP addresses. Those addresses route traffic onto AWS's private global network as early as possible. It then continuously steers requests to the nearest healthy endpoint. This is especially valuable for gaming backends, financial trading, and video conferencing, where every millisecond counts. A good practice is pairing Global Accelerator's health checks with your own application readiness checks. 4. Shield CloudFront with Web Application Firewall for edge security filtering. Route 53 directs traffic through Web Application Firewall for inspection. This happens before traffic ever reaches CloudFront. It adds a security checkpoint at the front door of a public-facing application. WAF rules catch SQL injection and cross-site scripting. They block these before requests reach cached or dynamic content. CloudFront keeps caching legitimate traffic for fast delivery. Together, this stack provides a meaningful layer of DDoS resilience. Malicious traffic gets absorbed at the edge. It never reaches origin infrastructure at all. It's essential for any public-facing application handling sensitive data or payments. A practical tip: start new WAF rules in count mode. That way, legitimate users don't get caught before you trust a rule. 5. Trigger Lambda from API Gateway for serverless AP-IS. Route 53 routes requests to API Gateway endpoints. Those endpoints trigger Lambda functions. This forms a serverless architecture with no infrastructure to manage. Why go serverless for this API layer? Lambda functions execute business logic on demand. They scale automatically with traffic. There's no server capacity to provision ahead of time. A PI gateway also throttles traffic and enforces usage plans. That shields back-end Lambda functions from sudden traffic spikes. This combination suits microservices and mobile backends. It also fits webhook processors that react to events without a dedicated server. 6. Layer web application firewall and CloudFront over S3 for protected content delivery. Route 53 directs traffic through web application firewall and CloudFront. From there, it reaches content stored in a secured S3 bucket. The S3 bucket is locked down with origin access control. All requests must flow through CloudFront instead. This closes off a common misconfiguration that exposes buckets publicly. This layered approach means DDoS mitigation and caching happen first. Traffic never touches storage directly. It's a strong fit for protected digital assets and secure downloads with signed URLs. It also suits subscription-gated content. A practical strategy: use CloudFront signed URLs. That way, authenticated users only get time-limited access. We have a lot more about this on systemsarchitect.io. See the full section there. Also, make sure to like the video and subscribe to the channel for more, and check the video notes for links. 7. Build a container stack with ALB, EC2, and RDS. Route 53 routes traffic to an ALB. The ALB distributes load across containers on Amazon ECS. Amazon RDS sits behind them as the persistent database. ECS scales running tasks automatically based on CPU or memory. RDS handles backups, patching, and multi-AZ replication for failover. Containers are stateless here. Any of them can be replaced without risking application data. All persistent state lives in RDS instead. This architecture suits containerized applications needing reliable relational storage. It fits e-commerce platforms and internal business tools alike. As a rule of thumb, keep database connection pooling in mind at the container layer. Scaled out tasks can otherwise exhaust RDS connection limits. 8. Run Lambda at edge on CloudFront for dynamic edge personalization. Route 53 sends users to CloudFront. CloudFront invokes Lambda at edge functions to process requests. This happens before content is served from an S3 origin. The logic runs closer to the user, not at a central server. This opens the door to rewriting URLs on the fly. It can also serve different content by device type. It can even manipulate images on the fly. Because these functions run at the edge, the added logic introduces minimal latency. That beats routing the same decision back to an origin server. This pattern suits content personalization and A/B testing. It also fits dynamic image resizing based on the requesting device. A practical tip: keep Lambda at edge functions small and fast. Latency compounds across every edge location otherwise. 9. Pair API Gateway and Lambda with DynamoDB for full-stack serverless APIs. Route 53 routes API requests through API Gateway. API Gateway triggers Lambda functions. Those functions read and write data in Amazon DynamoDB. This completes a serverless stack from domain name to database. Why pair Lambda with DynamoDB instead of a traditional database? DynamoDB is a fully managed NoSQL database. It scales throughput automatically, pairing naturally with Lambda's own on-demand scaling. The entire request path can scale from a handful of daily requests to a sustained high-volume workload. None of it needs manual capacity planning. This combination is a go-to choice for serverless backends, CRUD APIs, and real-time dashboards. A useful strategy: design DynamoDB access patterns up front. Performance depends on matching table design to your actual queries. 10. Combine CloudFront with ALB, ECS, and RDS for hybrid global delivery. Route 53 routes traffic through CloudFront to an ALB. The ALB distributes requests across ECS containers. RDS backs those containers as the database. This combines edge caching with a full containerized stack. CloudFront caches static assets at edge locations worldwide. RDS provides durable, consistent storage for transactional data. This stack lets one application serve both a marketing front end and a data-driven back end. Each layer scales independently. ECS handles compute-heavy periods. RDS and CloudFront scale on their own timeline. A practical tip: set explicit cache behaviors in CloudFront. Separate static paths from dynamic API paths. 11. Layer Web Application Firewall and CloudFront over API Gateway and Lambda for secure APIs. Route 53 routes traffic through Web Application Firewall and CloudFront. From there, it reaches API Gateway endpoints that trigger Lambda functions. WAF filters malicious requests first. CloudFront absorbs and caches the filtered traffic. API Gateway routes what passes through to the right Lambda function. This layering gives an API DDoS mitigation and response caching. It also adds automatic scaling, all in one architecture. It's particularly valuable where both security and performance are non-negotiable. Think financial services or healthcare data endpoints, handling regulated information. A good practice: set CloudFront cache TTLs conservatively for API responses. A stale response cached too long creates privacy issues. 12. Combine Global Accelerator with ECS and Aurora for global high availability. Route 53 works with Global Accelerator to route traffic optimally onto AWS's global network. That traffic reaches an ALB distributing load across ECS containers. Amazon Aurora serves as the database behind them. Aurora offers a MySQL and Postgres compatible engine built for high availability. It also gives fast, low-overhead read replicas spanning multiple availability zones. Health checks and failover happen at several levels at once. Global Accelerator, the ALB, and Aurora can each recover independently. That layered redundancy makes this one of the more resilient architectures on this list. A failure at almost any single layer gets absorbed. A practical tip is testing regional failover deliberately and regularly. An untested failover path is one of the most common ways high availability architectures fail when needed most. Thanks for watching and listening to this, and subscribe to the channel. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io.